Okay, Tech Time Traveler here, and I have another acquisition. This came in the mail just today from Australia. I actually just bought it a couple weeks ago, and it showed up faster than things show up from the US. I don't understand. When people ship stuff up to me from the US, sometimes it can be like 2 months, but when it comes from Australia, for some reason it gets here within, 5 or 6 days. I don't know if it's just because there's fewer stops in the middle or what the deal is, but so yeah, this little computer comes from Australia, and that's kind of appropriate in a way for our area because our area has a lot of Australians in it. I'm just south of Whistler, BC. If you go up to Whistler one day for a ski, you're going to find a lot of Australian accents up there. We kind of joke that Whistler is actually the real Australian capital. I'm not sure how that happened, but yeah, for some reason, Australians really gravitated towards skiing and other recreation here in BC, and a lot of them have settled here. So yeah, it's kind of nice to have a piece of the old country here in New Australia. And yeah, I think a lot of us here in North America don't fully appreciate the contributions of other countries to our digital heritage, so to speak. And I think that's because a lot of the big events in computing history happened basically here in North America, specifically the United States. Things like the invention of the transistor, the integrated circuit, microprocessors, most of that stuff happened over here. And a lot of the first microcomputers happened over here. So you do kind of get blinkered a little bit and focused on your particular region. You forget that there's a whole wide world out there where other stuff is going on. I've actually got a few pieces of Australian history. I have this Dream 6800, or it might more technically be called the Dream 6802. And I also have that S100 CPU card partially built. And then of course, I have a Micro-B because you just can't have an Australian computer collection without having that. So yeah, let's pull this out here and I'll show you what it is. It's very well wrapped, which is nice. And it's small. So shipping wasn't too bad. Okay. And it is wrapped in foil. Okay. Flip it around. Da-da-da. Look at that. Okay, and there we have it. That is the Talking Electronics TEC-1. Z80 based single board computer designed and produced in Australia by John Hardy with assistance from Ken Stone. I think Ken Stone was responsible for the layout. This computer came out in 1983. It was featured in Talking Electronics magazine, which had been being produced for a few years, I think, before this came out, and they basically produced various electronic kits. All kinds of stuff, things like burglary alarms and whatever gadgets might have been popular at the time. And yeah, this little machine was produced actually for quite a long run, I think in excess of 10 years, right into the mid-90s. We can see some of the chips on the board here actually have date codes in the 90s. But yeah, there is a reproduction version of this that's still being made today. And I'll link the website if you're curious. I think Ken Stone is still involved with it. But I'm told by Ken that this is an original based on the handwriting on the EEPROM there. Apparently they recognize the fellow's handwriting. And yeah, this is the revision D. There were 4 revisions, I believe. And this was the last one. There was a slight revision to the PCB. It was done by CAD Design, and they changed a couple of chips. But otherwise, it's essentially the same computer. Looks like this little thing is falling off here. But yeah, pretty much your standard single board computer in many ways. You've got your hexadecimal keypad. You've got a 6-digit, 7-segment LED display here. And then one thing that you don't typically have on a single board computer is a speaker. So I know what you're probably thinking. You're like, ooh, Talking Electronics, it must do speech synthesis. As far as I know, it doesn't, but it does do kind of like a PC speaker beeper kind of sound. So it can do music and things like that for certain games, just basic music. I think they did produce a speech synthesis module for this. There were a whole bunch of add-on projects that you could tie into one of these. And yeah, I mean, pretty simple, pretty small, kind of comparable in size to another Australian machine called the Dream 6800. You can see they're both pretty close. The Australians seem to like to keep things simple and neat, and I kind of respect that. I've seen some really messy American designs, but yeah, it fits in nicely with my small Australian vintage computer collection. I really don't have a lot. The Australians are kind of reluctant to give up their technology, mainly due to shipping. Yeah, so what I thought I would do is I would hook it up here, fire it up and see what it can do. And to aid us in our quest, I've printed off a portion of the original magazine article that featured this. Looks like it retailed for about 19 bucks just for the board and about $68 for the PCB. And yeah, they expanded on it over the years. They revised it several times, but this is essentially the same computer that it was in 1983. It's functionally identical. So yeah, let's set up here and we will have a look. Okay, so for starters, we'll just kind of go over what we've got on this board here. So basically, we've got a Z80 CPU. I think it's running at 1 or 2 megahertz. I'm not 100% sure on that. And then we've got a clock generator. It's a RCA 4049 type. And then we have a couple of 273s, which drive the segments on the display. Earlier versions of the TEC use the 8212, which are a much wider chip. So that's one way you can distinguish them from the later versions. And I don't know if it was a thing or not, but the earlier versions have these kind of puffy calculator style colorful keys, whereas this one doesn't. I don't know if the owner just didn't add them or if they just weren't available anymore. We've got a single 6116 by 8-bit memory chip there, which gives us 2 kilobytes. And we've got a 74LS138, which selects between ROM and RAM. We've also got an expansion port there in case you want to add things to the machine. We've also got a really nice convenient place to hook up our logic probe, which is something I'm really loving about this right now, because so many times I'm probing on other machines and there's not anywhere convenient to hook up. And then we've also got a bridge rectifier set up over here so you can connect any 9 to 12 volt AC or DC power source. It apparently doesn't care. And of course we've got the speaker, which again is not something you typically saw in single board computers at the time when this first came out. I'm trying to think of any single board computers from early 80s, late 70s that had a speaker built in, and I can't think of one off the top of my head. I'm sure there must be one out there. And then we've got a 2716 EEPROM, which contains a bunch of sample programs and also handles some of the basic functionality of the device, I think. So that's kind of cool. And that's very much like the Dream over here. The Dream also has a ROM on it, and that's what's used for their Chip OS or Chip 8, whatever they refer to it as, for helping to program games a little more easily. So yeah, I think basically what we can do here is hook up power. And yeah, I've got a printout of the original magazine article, which I'm hoping will be a guide here because I have absolutely no idea how to operate this thing. So you're seeing sort of how things are when I get a new machine that I've taken an interest in but have never actually used. So this could be a little bit painful, but I think this machine has a reputation for being relatively easy to work with. So I think we should be okay there. Yeah, the ROM chip contains a bunch of programs, sound demonstrations, basic things that demonstrate the functionality of the computer, like creating a tune or, creating a moving letter or stuff like that. And the piece de resistance is there are 3 games that are loaded up into ROM. We have Luna Lander, which is basically a lunar lander style game. We have NIM, which I'm not really sure. It's like a matching numbers game. And then we have Invaders, which is probably as close as you can get to a real shoot 'em up arcade style thing on one of these. So yeah, I think this should be really interesting. Okay, so we'll just get our wires hooked up here. And I'm just using a 12 volt adapter I had lying around from one thing or another that is long since gone. Kind of justifies keeping stuff. And there we go. So we got our display up. Seems to be working perfectly. I'm not sure what these standoffs are for. I'm guessing you could put it under some kind of a display cover or something, but I don't know why you'd want to do that, because then you couldn't access the keypad there. Okay, well, let's take her for a drive here. Okay, well, I guess we'll start off with experiments for the TEC-1. These were intended to basically give you some familiarity with the system. And the first thing that we have is a welcome message. So to call it up, we do reset. And then we type D1 plus, so we're incrementing now, 0, 2, and then address 0, 2, 7, 0, go. Nice. Come to the TEC-1. Designed by John Hardy for something. I'm not sure what that was. Well, that's cool. It's kind of a write-friendly single-board computer. Okay, experiment 1. To examine the increment of the address. Procedure. Turn the TEC-1 on and look at the address display. All right. I'm just going to pretend I just turned it on. When the TEC is first turned on, the first available address is 0800. This can be incremented by pressing the plus key. Yep, you can see the addresses going up there, and it's showing us the contents for each. Okay, and that will increase to take you to the next available location. Carry out this procedure by pressing the plus key and watch the display 01, 02, 03. Yep, so we've seen all that because I jumped ahead because I'm a twit. And then the TEC-1 is programmed in hexadecimal, in which 4 binary lines are grouped together to form a hex number. In this way, we can write binary numbers from 0000 to 1111. And this means that we can go higher than 9, as 9 is only 1001 in binary. So yeah, they're just explaining how hexadecimal works. I've covered that in my Ohio Scientific 300 video. If you haven't seen that, I encourage you to check it out. It's a little bit rookie-ish because it was the first video I ever did that was sort of a formal presentation, but that's basically converting binary into hexadecimal numbers, which is what makes it a little bit easier for human beings to understand. So their first experiment then is studying hex. To study hex notation and count in hex. Study the hex notation in experiment 1 and answer the following set of problems. Use your TEC-1 to verify your answers. A program starts at 0800. What are the next 21 addresses? Well, that's obvious. We just 2, 7. I mean, this is all nonsense, but yeah, that's pretty basic. A program starts at A00. Complete the following set of addresses. Okay, so I mean, obviously we would hit address, and then we would do, let's see if I get this right, 0A00, and then we would just start hitting plus, A01, 03, 04, and on it goes. Yeah, so that's pretty rudimentary stuff. Experiment number 3, creating a beep. To create a tone or beep on the TEC-1, the theory is the 2716 has been pre-programmed with a loop to give a pulse to the speaker. Depending on the speed of the system, the tone of the pulse will be varied. Okay, yeah, well, I would hope they would know for sure that there was something on there. It's not just a theory. We can address the beginning of this routine by pressing the following keys: reset, address. So now we're going to address 018, and then E, and then go. Okay, I don't know what that did. You'll hear 2 beeps, which we did. And by turning the speed control down, they will become separated. The first beep is the one you have programmed. In the next experiment, you will change the frequency of the beep. When the TEC-1 is reset, the decimal data points appear in the data readouts. This indicates the data can be changed by pressing the key 0F. By pressing the address key, the dots will appear in the address readouts. This indicates this can now be changed by pressing the keys 0 through F. Okay, what other deviltry can we get up to here? Creating a beep. To create a tone or beep on the TEC-1, the theory is the 2716 has been pre-programmed with a loop to give a pulse to the speaker. Depending on the speed of the system, the tone of the pulse will be varied. We can address the beginning of this routine by pressing the following keys. Reset. Okay. Address 0, 1, 8, and then E, go. You'll hear two beeps, and then by turning the speed control down, they'll become separated. Well, I'm hearing a lot more than two beeps there. But let's just adjust the... Okay. And if we turn it up... Oh, that's cool. Okay, that's getting annoying. So that's creating a beep. So yeah, this is a speed control. So I guess, unless I'm misunderstanding, the CPU speed can be adjusted, and that affects the speed of pretty much everything on the machine, including the tones. Yeah, see how it's gotten lower? Well, it sounds more like a cash register now. Experiment number 4, creating a tone or note. To create a tone, it is possible to produce a tone from the speaker, which is the result of a routine in the EEPROM. To create a single note or tone, press the following. So do reset, and then we do 2 plus 8 plus 1 address 1 B 0 go. That reminds me of like, oh, what does that remind me of? It's like the, when something bad would happen in one of your Sierra adventure games. Hang on, address 1 B 0. Interesting. So only the first note to be heard in the speaker is the product of our programming. The other beep or beeps come from the routines. The number 1 in the routine above selects the particular note. It can have one of 24 different values, and thus we can create different effects as shown later in an experiment. To create a single note with a period of silence, the instruction for silence is 00. Run the following program. So 2 plus 8 plus 0 address 1 B 0 go. Yeah, so that's the basically doing a gap there. And then we can create a scale. We'll do a reset. And then we'll do 2 plus 8 plus 1. B 0 go. And that's our scale. I don't know where that last bit comes from. And then of course if I were to dial up the speed, and do address 1B0. Go. Nope, so I'd screw that up. Address 1, where's B0? Go. Yeah, so that's with the speed down. Cool. Now they do go through a bit more of this here, you know, how to create your own tune, and they've got some notes written out on a table here on the other side. So basically each note has a hexadecimal value you can enter and basically create your own music. I'm not going to do that because it's going to take a while. Now let's see what else we got here. Experiment 6, creating a running letter. To produce a running A, press the following sequence of keys. Reset, 2 plus 8 plus 1 plus 0 plus 0 plus 0 plus 1 E, and then address 270, and then go. And this is supposed to produce a running A, so I'm guessing what they mean is it goes across the screen somehow. So let's see if this works. Yeah, there we go. Well, that's cool. The letter is being shifted one place to the left by the routine at 270. The letter can be made to travel the full length of the display by adding further zeros to the program. So if we do reset, and then we do, there's our keys here. That's 8 plus 1 plus 0 plus 0 plus 0 plus 0 plus 0 plus 0. So we're adding zeros to force it further across the screen. Plus 1E, and then we do address 270, which is where we're going to execute from, and then we do go, and then go. It should come all the way across now. Yeah, perfect. Look at that. I've tried doing exercises on other single board computers, and for some reason I could never get it to work this well. So yeah, this thing's working really well. I'm finding this machine to be a lot easier to work with than some of my other single board machines, because I've entered experiments like these from other computers like my OSI 300 and always kind of run into some kind of a problem or another, but this is really, really straightforward and simple. Combining words with a tune. This is experiment number 7. To combine a tune and running words in one sequence. So it's going to make letters dance and it's going to do a song at the same time. The program we will be writing in this experiment consists of a set of instructions, and included in this are 2 call statements, call 1B0 and call 270. So I believe those are where certain routines are already programmed into the EEPROM to allow you to do this stuff, followed by a pitch table and a letter table. Now, I'm not going to go through the entire wording of that. If you ever decide to pick up one of these, you can absolutely do that yourself. But here is the program. And we can see it's got the instructions spelled out here along with the hexadecimal machine language instructions that correspond to that. So I think this is loading the accumulator and then with 00. And so each of these hexadecimal notations on this side here are the equivalent of what is being instructed over here. So what we want to do is push ++ to get to 802. Now let me just check this. Yeah, it looks like. So at address 802, the instruction 3E tells the accumulator to load the immediate byte, which is 00. This takes up 802 and 803. The program starts at 800, and the first 2 bytes we will store at the address of the pitch table, which is basically our notes, which starts at 900. Later, the computer will store the letter table, and this will be repeated over and over again as the program contains a jump or repeat instruction. Okay, so let's go see what they're doing here. Yeah, this just sort of explains how the program works. So it's basically got a pitch and a letter table, and it basically uses calls to go to each of those, pick them off, and then use them. So for 800, since the pitch table is going to be at 0900, we want to do 00. And then we want to move to, and then basically we just follow the instructions here or here. This is just written out for people that are newbies to this sort of thing, but I think I can handle this. 3E plus 00. So now we're on to 804, which is 3200 plus 0. Okay, to run the program, press reset, plus, go. It didn't seem to work. Okay, I must have goofed somewhere. So let's just see what I did wrong. It's 0009 3E 032. Oh, I see. I goofed. I didn't put the pitch and letter tables in there. Okay, so we got to go to 09. Oops. Address 0900. Okay, so now we put in 01. Okay, so let's just check that. 01. Okay, and now I just got to do the letter table. So you got 0, A00. Let me switch. And I don't know if I mentioned this, but if you look at where the dots are, that's what you're basically entering into. So if I have address here and it's got the dots there, then I'm changing this. If I have it over here, then I'm changing the values. Okay, so let's just go back to A00, make sure that's right. 1, 2, 3, 0, 0, 0, 0, 0, 0, and F. Perfect. Okay, let's try this again. So we're gonna go plus, go. And there's our letters. Yay. I guess that's all we got. Just A, B, C, and some blanks. Okay, well, let's just crank the speed up here because I want to see if this can go a little faster. Nice. All right, well that covers the main experiments. Now we should cut loose here and have a little bit of fun. So there are, as I mentioned, 3 games that are programmed into this system. One is NIM, one is Luna Lander, and one is Invaders. NIM is some sort of a matching game. I sort of vaguely remember. So you are playing against a computer in a battle of wits. The computer has an obvious advantage. There are 23 matches, and you take turns in removing 1, 2, or 3 matches. The object of the game is to make the computer take the last match. At each turn, you can only take 1, 2, or 3. The number of matches is displayed on the last 2 digits of the display. When you press a button, say 3, this will be displayed as I or Y3. It would be a Y because it can't display that. This indicates you took 3 matches. Then it will display I3. This will mean the computer took 3 matches. Okay, so I guess somehow it could display a Y, but I don't know. It is now waiting for your next move. Be careful, the computer is smart. It is waiting for you to make your first mistake. It will then take immediate advantage of it. If you're playing a purely random game, you will find yourself holding the last match every time. The computer is a pretty bad loser, but thankfully it doesn't self-destruct in disgust. If you're playing a careful, well-calculated game, you can win, so try your skill and take the winning message. Okay, I have no idea what this game is about, so we're just going to go to AD. I'm going to go to the address where this program resides in ROM, which is A30, which is 3E0, and then go. Like, what do I do with that? Like, I don't know. You lose. Stupid. That's nice. Those Aussies, they don't worry about your feelings too much. Yeah, I really don't know how to play that at all. I mean, it seems like you're just matching the numbers that are on the display. I don't know. Yeah, this looks like pretty much the standard lunar lander style game. We have 20 liters of fuel left, and we are trying to land the spacecraft without denting either the moon or the craft. And yeah, gravity is constantly pulling you down, and basically the goal is you got to slow the thing down just enough to touch down softly. You don't want to use too many units of fuel because you'll go flying off into outer space. And yeah, basically you just use the plus key. So you're just trying to time things correctly so that it just gracefully touches down the surface of the moon and doesn't crash. And yeah, looks like it could be fun. You know, I feel like for this one, we need a little bit more atmosphere. Yeah, there we go. All right, that kind of raises the stakes a little bit. All right, so let's just start this thing up. I'm going to bring the lunar module to life. Go. All right, beginning descent sequence now. Oh, there's my 20 units of fuel. I'm falling very quickly. This plus key is not working properly. Hello. I feel like that's a bad thing. All right, here we go again. Okay, come on, stupid retro rocket. There we go. Oops. This is not good. Only got like 6 units of fuel left. Houston, we seem to have a problem.
Hey, well this is Houston. What the hell are you doing up there?
Okay. Nice and steady. That's the way to do it. Yes! I lived. Huh. There's the last Radio Shack. I heard there was one Radio Shack still open. I just didn't know it was up here.
Hey, Eagle, this is Houston. Can you pick up some diodes while you're up there?
All right, so let's check out Invaders. The object of Invaders is very simple. You shoot anything that moves. Your position is represented by the number on the left. The invaders appear from the right. They shift across the display, and if they touch you, pow! The game ends and the score is shown on the screen. You can't stop the invaders advancing, but you can defend yourself by blowing them up. The fire button is button 0, but you can only destroy those invaders which have the same number as your space gun. To change your number to match the first invader, press the plus button. You can only increase your number, not reduce it. By using the plus key and fire keys, you will be able to keep the invaders at bay. To improve your skill, advance the speed control. You can also destroy those behind the front invader by matching the numbers. Interesting. Okay. Try your firepower. You will find it most absorbing. Alrighty then. So that resides at 320. So address 320. So I just gotta familiarize myself. Plus is here, 0 is there. So yeah, basically they're gonna be coming this way. They're gonna be a sequence of numbers, and you have to make your gun match the number that's coming at you or one of the ones behind it before you fire. And basically you're just trying to keep them from touching you. Okay, I can do this. So that's 7 plus 1 plus 3. Shoot plus 3, 4, 3, 6, 0, 1. And yeah, this will just keep going on. Oh no. No. All right, well, I got 16. That's not bad. Let's see what happens. Let's make it interesting. We'll crank the speed way up. Okay, let's go. Oh wow, that's yeah, that was a predictable score for that. Oops, I'm firing the wrong thing here. Okay, 1, 2, 3, 4, 5, 6, 7. Oh yeah, no, this is not possible. No. My reflexes are not good enough for that. Let's turn that back down a bit. And play again. 1, 2, 3, 4, 5. 1. Oh no. Yeah, no, lost. 5. 6. 4. 1. No. Yeah, that one's interesting. I could see myself playing that a little bit when I was younger and trying to get to the highest possible score. And there you go. Those are the 3 programs that you get with the EEPROM that you purchase from Talking Electronics if you build a TEC-1. All right, well, that's it for our video on the Talking Electronics TEC-1 computer from around 1983 to the mid-90s. And yeah, it's a fun little piece of Aussie tech. It's quite compact. And it goes a little bit beyond what your typical single board computer typically has. Your typical single board computer is more of a learning device and it's kind of dry programming stuff. This gives you a little bit of fun in addition to learning how to actually use a microprocessor and give instructions and program and stuff like that. So yeah, I definitely think it's well worth the little bit of money I spent on it. And yeah, if you're interested in building your own and learning how to use one, they still produce these apparently. There's a reproduction board that's available. I'll put a link in the description that basically shows you how to find it. And yeah, this thing can do a whole lot more than just what I've demonstrated here. I just didn't want to do like a 2-hour video. But there are some expansions, I understand, that can be put together using this expansion port here. And yeah, there's just many different things that Talking Electronics offers in addition to the tech. They have a whole bunch of other electronics kits, so definitely encourage you to check that out. There's so many little projects there, and I could probably spend an entire year just monkeying around with what they've got there. But anyway, it's a nice little addition to my small but growing Australian computer collection. You will see these other machines in the future at some point when I get to it. I've just got such a backlog right now. I am working on the mindset video. I keep saying that every single video that I do. But I am pleased to report that I actually got the video titling system, the gen locking, to actually work. And that was one of the things that I wanted to have before I actually went forward and released that video. I've also come into possession of a whole bunch more information on the later days of Mindset, including some models of Mindset I didn't know existed. So all of that's going to be incorporated into that video. Really hope I'll have it out soon, and that I'm not overhyping what you're going to get, but I just wanted it to be a little bit more in depth. There already is a Mindset video out there by David, the 8-bit guy. Excellent video, as always, good little overview, but there were a few things that obviously he didn't have the ability to demonstrate, and I just kind of wanted to go in there and show those features off, particularly the gen locking, because that's something the Mindset is known for. Anyway, that's it for this video. Thanks so much for watching, and we will see you again soon.